15A. So Sam plays a game with his sister Annie. Well, first of all, we talk about the linear combinations of random variable. Do you know like linear combination in methods? Like that's exactly the same thing. Linear combination, like AX plus B. Like that's a linear combination. And then if we say expected of AX plus B, that is A expected X plus B. And then if we say VAR variance of X plus B, that is A squared variance of X. If we say SD AX plus B, and that is absolute A SDX. Right? Okay, so let's have a look at the first question here. It's just connect with the methods course, I think, where this point starts. It's just connect with the methods. Example 1 says Sam plays a game with his sister Annie. He tosses the coin 3 times, okay, 3 times, and counts the number of times that the coin comes up heads. Okay, I want to see a head. Annie charged him $5 to play, and give him 2.5 for each head that he toasted. Okay, let X be the number of heads observed in 3 tosses. What X could be? X is a random variable.
0, 1, 2, 3.
Yeah, 0, 1, 2, and 3. So that's 3 toasts. And express W, the net amount he wins in terms of X. So each X he got, he will earn $2.5. So W just equals to 2.5x minus 5, because you need to pay the $5 at the beginning. So you gain, subtract, you lose. That will be the net amount you win. Does that make sense so far? Okay, B. What is the probability distribution of W? What is the probability distribution of W? Okay, so the probability distribution is the table thing. Okay, is the when we set up the table for X 0, 1, 2, 3. Remember that table? Okay, so we have to think about this table. Well, let's make a 3-row table. Okay, the first row let's do, well, the second row let's do X. The first row do W. And then let's do probability of X equals to X. That will be the same as probability W equals to that, so same probability. Okay, what X could take? You just said that. 0, 1, 2, 3. That's what X could take. Then what W will be?
Negative 5.
And 2.5. Okay, then what's the probability that I want to get a 0? I toss the coin 3 times. What's the probability I can get 0 head?
To say up and up.
That's half, which is 1/8. What's the probability you get 3 heads? And what's the probability you get 1 head and 2 heads? Well, that question appeared again and again, 3 A's. So it's the tree diagram. Head, tail, head, tail, head, tail, head, tail, head, tail, head, tail, head, tail. And you want how many? 1 head. Okay, 1 head will be 1 head here, 1 head here, and 1 head here. Okay, and this one is 2 head, 2 head, and 2 head. So 3 on 8, 3 on 8. Okay, C. What is the probability that the net amount of he wins in the game is more than $2? So you want probability that W greater than 2. What is the probability?
1/8.
Yeah, 1/8 only. Okay. Easy question. Do you have calculators here? Have your calculators out there. Because I don't want to do this by hand. Okay, next one. This is a discrete random variable, right? This is discrete random variable. So if x is discrete random variable, then y equals to a plus ax plus b is also a discrete random variable. Okay, just like that. X is 0, 1, 2, 3, then w can take 4 values as well. And the probability share the same probability with that x. Okay, let's have a look at next one. If x is a continuous random variable, then y equals to x plus b, this is a linear combination again, is also a continuous random variable. We know that a continuous random variable x has a probability density function, right? Remember what is probability density function for method? Everything above the x-axis or equals to 0, and everything under the curve should be 1. Most of the time it can be a hybrid function with 0 on the other side. And then we have like x less than c will be negative infinity to c, integral of that, finding the area under the curve to find the probability, right? And now if we have y equals to x plus b, we want to find the probability y less than a number. Y equals to what? Y equals to ax plus b less than y. And then I want to find that is x is less than y minus b divided by a. Just rearrange that to make x on the left hand side. And then probability of y less than a number will be the same as probability x less than that number. We have the distribution for x, fx. So that's negative infinity to that point of fx, dx. Okay, it's very easy thing. Just do not think about too difficult. And then that's the two formula I mentioned. Aex plus b is a expected x plus b, variance x plus b is a squared variance of x. This works for both discrete and continuous. Okay, let's have a look at example 2. A random variable x has probability density function fx equals to that. Find the probability x less than 0.8. Okay, can you have your CAS out and then do this on your CAS, please? Do you have that for the first one? Mm-hmm. 0.648. Okay, B. Let y equals to 4x plus 1. So you want to find probability y less than or equals to 4. That is the same as you find probability 4x plus 1 is less than or equals to 4. That's probability that x is less than or equals to 3 on 4. Right? So that is integral from less than that. 3 on 4 is the highest point and half is the lowest point of fx. What do you have? Half. You need to know how to use your calculator. That's quite important. Okay, C. Okay, do you remember how to do expected value and the variance for a continuous random variable? Okay, expected value is times x and fx. So expected x will be integral from a half to 1 of x times fx dx. Okay, that's the thing you learn in method, which is very important. That's 3 on 4. Okay, that's 3 on 4. Expected x 3 on 4. Okay, variance. There are two formulas for variance. The normal used one is the expected x squared minus expected x and then square the expected x. Yes? You can find expected x squared. Expect gx, remember expect gx is integral from half to 1 gx times fx dx. So whatever you have in the bracket, you times it in the integral. That's how you find expected gx. Or the second formula we have is variance x equals to expected x minus mu squared, then find that expected value. But that is normally not used, but you need to know it. Sometimes we need to use that. So this is the common use one. It's okay, expected x squared minus expected x and then whole thing squared. So we'll use this one. We need to find expected x squared. That is integral from half to 1 x squared times fx dx. That's squared. 23 on 40. 23 on 40. So variance of x is 23 on 40 minus bracket 3 on 4 squared. Ex squared minus mu squared. Okay, mu squared. One on 80. Okay, 1 on 80. Okay, last one is D. D is asking expected y. expected y is expected 4x plus 1. That is 4 expected x plus 1. And that is 4. So 4 times 3 on 4 plus 1, that is 4. And variance of y is variance of 4x plus 1. That is 16 times variance of x. That is 16 times 1 on 80, which is a 1 on 5. Okay. Okay, done with this. Okay, next one. Before we talk about only two random variables, right? Like x and y, two random variables. One random variable x, like expected x or expected y. And then we think about how about expected ax plus by, like a combination of two random variables. Okay, a combination of two. Like you add, for example, x follow a distribution, y follow a distribution. I add those two together. I want to know what's the expected value you're adding them together. Okay, so this thing we talk about is for random variable. First of all, you need to know that's independent events. Okay, all the things you add together needs to be independent events. If not independent, it's hard. It's not following this rule here. Especially the variance one. The variance one will be wrong. So you have x and y. Then expected x plus b is it is expected ax plus expected by, and that's a expected x and b expected y. And then have a look at this one. If you have more, you have x1, x2, x3, x3, and 2 xn. Okay, you have xn. So that will be a1 ex1, a2 x1. Like it's just a linear transformation. It's very easy to think about. For variance, okay, independent. It must be independent. If x and y are not independent, this rule is wrong. Okay, it's not just not working. It's wrong. Definitely wrong. So if it's independent, then okay, this one can be variance of ax plus variance of ay, and that's a squared variance of x and b squared of variance of y. And same happens here. Okay, if you plus all of them, it's a1 squared variance x1, a2 squared variance x2. Okay, please write one thing beside here. What is the variance of ax minus by? Oh, how do you know that? Oh, you did it. Okay, so that's a variance of ax plus variance of negative by. Okay, and that is a squared of variance x plus b squared of variance y. Okay, the minus and plus is the same because you will square it. Okay, that's important because later on we'll have one question and it's exactly doing that. And you get it wrong. And you have variance 0. Okay, that's the rule. Let's have a look at example 3. Okay, example 3 says the random variable x is the score of an ordinary fair die is thrown. And the random variable y is the number of tails when a fair coin is thrown once. Okay, throw once. So for x, well, the distribution for x, probably x equals to x, that just will be 0, 1, 2, 3, 4, 5, and 6, right? And all this probability is 1 on 6. Wait, what I have? Why I have a 0 here? No zeros. No, die. 1, 2, 3. 1 on 6. 6 and 1 on 6 for all of that. Okay, for distribution y, what I should have for distribution y? Half? 0 and 1. Y equals to y. What's the probability of getting 0? You tossed a fair coin. You want ones. You want not tail. Then there's a head, which is half and half. Right? Okay. That's the distribution for x and y themselves. Okay. Then A is asking expected x. So that will be easy. It's 1 times 1 6 times 2 times 6, 3 times 1 6, 4 times 1 6, 5 times 1 6, and plus them together. Right? Expected value. So it's 1 plus 2 plus 3 plus 4 plus 5 plus 6 times 1 on 6. Okay, 1 plus 2 is 3, 6, 10, 15, 21. 21 on 6. That's a 7 on 2. If I want to know variance of x, I need to know expected x squared minus expected x. Well, I would say that's a mu squared. How do I find expected x squared? Squared x, 1, 4, 9, 16, 25, 36. So you have 1 plus 4 plus 9 plus 16 plus 25 plus 36 times 1 on 6 minus 7 on 2 squared. That is 5, 10, 14, 13, 30, 40, 50, 60, 80, 90, 91. Yeah, 91 over 6. Minus 49 over 4 is a 12. So it's a 35 on 12. Correct? Okay, for part B. Expect 6y. So let's have a think about expected y first. What is expected y? Half. 0 times half plus 1 times half. That's half. What's expected y squared? Half. One squared, 0 squared, and 1 squared half. Okay, so what's variance of y? What's variance of y? Yep, half minus half squared. That is quarter. Okay, what I'm asking is expected 6y. So that's 6 expected y. That's a 3. Variance of 6y is 36 of variance y. That's a 9. C looking for expected EX plus 6y. So expected x plus expected 6y. So expected x is 7 on 2 plus expected 6y is 3. 30 on 2. Right? Variance of x plus 6y. is variance of x, which is 35 on 12, plus expect 6y, variance of 6y plus 9. That 12 plus 9. Okay, 35 on 3. Oh, sorry, 5, 35. 143 on 12. All good so far? Okay, we may have one nice one. And then we'll go to the terrible part. Yep. Okay, 15b. 15b is telling you that if x and y are normally random distributed variables, okay, independent normal random variables. Okay, just to remember what's normal random variables. Normal random variable. What's normal? What curve? The shape. Bell curve. Okay, bell curve is normal distribution. So the whole two chapters are talking about normal distribution. Okay, so not talking about normal distribution. You use normal distribution all the time. Okay, just keep using normal distribution. So first one tells you if x and y are normally distributed. Okay, then ax plus by is also normally distributed. It must be normally distributed. Okay, if you have two separate random variables, they are normally distributed already. Then class them together and have any linear factors times together. They added together. That new variable must be normally distributed as well if you sketch another curve. And then the expected x plus by is a expected x plus b expected y. Variance is a squared. Variance x, b squared, variance y, right? Then the new normal, let's say w equals to ax plus by. Then w will be normally distributed as well because x and y are normally distributed. With what mean and what standard deviation? The mean is just this mean. The standard deviation is just this standard deviation. Does that make sense? Like the new standard deviation and the new mean were created by calculate by that way.